Substance use disorders, models of addiction. This lecture introduces and critically reviews causal models of addiction. In class, I will introduce a triadic model of substance use-related problems, liking, needing, and craving, and will assert that the term addiction is best reserved for the craving type or level of substance misuse. This slideshow introduces you to the current models of craving level addiction. As I've already suggested, to fully understand the nature of substance misuse and addiction, one must look both inside and outside of the human body. Both perspectives are essential to a comprehensive and fully informed understanding of these problems. This lecture introduces the most salient inside the body models of craving level addiction. These models vary in terms of the putative core mechanisms of the addictive process, including the mechanisms of hedonia, moving towards pleasure or away from pain, motivational drive processes, and or explicit learning. Causal mechanisms of craving level addiction vary in terms of the putative core mechanism and whether this mechanism is comprised of explicit or implicit processes. Explicit processes are those that are cognitively mediated. The subject has or can have awareness of the mediating role that the process plays in drug use. Implicit processes are those that are not cognitively mediated. These must be inferred or deduced from the third-person observation perspective through the understanding of neurophysiological processes or through the understanding of involved brain systems, etc. Quote-unquote unconscious motivation, by the way, is not an implicit process for anybody except the most fundamentalist psychoanalyst. Explicit, the subject is or can theoretically be aware of what's going on. Implicit, the subject by definition has no access to understanding the whys and the wherefores of the commitment or the behavior. Back to causal mechanisms. Hedonic or affectively based mechanisms include explicit conscious pleasure. For example, I love the warm sensation of bourbon dropping down my throat, or weed makes me feel relaxed, as well as implicitly observed hedonic reactions, such as the lip smacking of an infant when given sugar, or the gagging of an adult after ingesting a piece of gas station sushi. Check out the Berridge babies for a presentation of implicit liking. By the way, the convention is to use quotation marks when labeling implicit processes. Learning processes include explicit learning. For example, I figured out that I'm sexier with a good buzz on, as well as the whole array of expectancies and beliefs one has associated with alcohol and drug use. Expectancies and beliefs, by and large, are explicit learning processes. Research has indicated that US children generally develop expectancies about alcohol and tobacco use, what's positive about them, what's negative about them, by first or second grade. Implicit learning captures mechanisms associated with classical and operant conditioning, both of which eschew the need for cognitive mediation in the learning process. The third causal mechanism, motivation, at the explicit level is very easy to comprehend. This is the bread and butter of decision-making processes, the content of pros and cons lists. Implicit wanting is a more elusive concept that we will explore in detail shortly. Implicit wanting is essentially a brain-level explanation of goal-directed behavior involving subcortical systems that are by definition unaccompanied by any cognitive mediation. Implicit wanting is inferred from our understanding of drug-related neurophysiological processes and also deduced from observed behavior. Here's the link to the Berridge babies, a wonderful example of implicit liking. Let's discuss the classical model of craving level addiction, known as the opponent process model. The opponent process model invokes implicit learning processes, most importantly classical conditioning, in the explanation of the cause of craving level addiction. This is the classic so-called opiate model of addiction, wedded to the pharmacodynamics of opioids and other depressant substances, including alcohol, barbiturates, and benzodiazepines. This model asserts that addiction is tied to the physiological changes associated with repeated use of drugs, i.e. to the tolerance withdrawal cycle. Once physiological dependence develops, the drug user experiences withdrawal symptoms as the drug leaves the body. It is, according to the opponent process model, this noxious state that drives repeated drug-seeking behavior. The addicted drug user is driven to reuse for the sake of withdrawal symptom relief. This is a classic negative reinforcement model of behavior. Furthermore, over time, this process generalizes such that the addict experiences symptoms of withdrawal even in the absence of a blood opioid, blood alcohol, or blood barbiturate drop, as a function of a process called conditioned tolerance or conditioned withdrawal. We will discuss these concepts shortly. In its simplest form, the opponent process model explains drug craving and drug seeking as a function of the implicit drive to relieve oneself of noxious sensations. So to what does opponent process refer? Opponent process refers to the two phases of the drug use experience. After ingesting a depressant such as an opioid, ethanol, a barbiturate, or a benzodiazepine, one experiences a positive drug effect, the high. As the blood level of the drug decreases, this A state is followed by a B state, which is what we refer to as the rebound phase or withdrawal. Typically, this B state is symptomatically the opposite of the A state, ergo the name opponent process. What goes up essentially must come down. The euphoria of the opioid rush is followed by the dysphoria of withdrawal. The anxiolysis of alcohol intoxication is followed by agitation, etc., etc. As one develops pharmacodynamic tolerance, which we'll discuss shortly, the A state effects decrease. However, the B state effects do not decrease and often get more extreme. This phenomenon is captured in the oft-cited addict's utterance, "I don't use to get high, I use to get normal." According to progenitors of the opponent process model, it is this exaggerated B state that motivates craving and drug reuse. Let's discuss tolerance and withdrawal, as they are key constructs in the opponent process model. There are actually a number of different types of tolerance. Metabolic tolerance refers to changes in the half-life or metabolic rate of a substance as a function of use history. Thus, when one is on a cocaine run, the metabolic rate increases over the period of use, such that later doses metabolize faster than do earlier doses. This process may also occur across episodes of drug use, so it is both a within and a between episode phenomenon. Metabolic tolerance decreases the length of the high, but not the intensity of the high. The intensity is the same, duration is shorter. One sees evidence of very little metabolic tolerance in the depressants, the opioids, ethanol, barbiturates, and benzodiazepines. Behavioral tolerance refers to the seasoned drug user's capacity to adjust behaviorally to the effects of intoxication. It refers to situations like the one wherein the seasoned drinker learns how to walk without swaying or to talk without slurring words, or to the cannabis user who learns to tolerate the derealization effects of high levels of cannabis intoxication. Behavioral tolerance is a learning process, and it is certainly evident in seasoned depressant users, but it is not of relevance to the opponent process model. Pharmacodynamic tolerance is at the center of this model's explanations of addiction. This refers to the selective adaptation of the central nervous system to the presence of the drug in the bloodstream and in the brain. To maintain a state of homeostasis, the body adjusts to the presence of the drug. Since the depressants decrease cardiac and respiratory rate, the body adjusts by raising these mechanisms to maintain relatively normal functioning during intoxication. Furthermore, body temperature adapts, as do mental states such as arousal, fight or flight processes, as well as functions of many other bodily systems. These processes of adaptation serve a fundamental survival function. They keep you alive. This adaptation occurs over time, both within and across episodes of use. During a period of use, the adaptation increases from hour 1 to hour 2 to hour 3 to hour 4. Across episodes of use, across the lifespan of the user, the adaptation increases also. This adaptation process, pharmacodynamic tolerance, is only observed with respect to the depressant class of drugs. One does not observe salient pharmacodynamic tolerance and withdrawal in the pharmacodynamics of stimulant use, cannabis use, or in the use of hallucinogens. Withdrawal is the term used for the second phase of the pharmacodynamic tolerance and withdrawal process. As the blood level of the depressant drug decreases, the negative action on body systems also decreases. However, the body is slow to adjust, i.e., there is a lag between blood drug level drop and bodily readjustment to baseline. This lag, the fact that bodily systems are still in adjustment mode, even though blood drug level has dropped, generates the symptoms of withdrawal. For example, during intoxication, blood pressure increases, as does respiratory rate, to adjust for the depressant effects of drugs on these processes. Drugs decrease blood pressure, decrease respiratory rate. Your body adapts a baseline level of blood pressure and respiratory rate that are above norms. During acute withdrawal, these systems are still accelerated. yielding a clinical picture of hypertension, agitation, etc. Withdrawal is said to be completed when the bodily systems have fully returned to baseline or normal functioning. The plot, however, thickens as the processes of pharmacodynamic tolerance and withdrawal can become conditioned or triggered by non-drug stimuli. There are powerful classical conditioning processes associated with the development of pharmacodynamic tolerance and withdrawal, yielding processes called situational tolerance and conditioned withdrawal. Situational and conditioned can be used here interchangeably. Over repeated episodes of drug use, the non-drug stimuli come to be associated with the drug effects and become conditioned stimuli of these CNS adaptational processes. Thus, for example, the environmental cues associated with the drugging occasion, such as the room, the paraphernalia, the people, the Jimi Hendrix music, all trigger the same adaptational processes as occur if and when the drug actually hits the brain. Importantly, this condition triggering occurs before and will also occur in the absence of subsequent drug ingestion. On the tolerance, or A side of this process, this serves a vital survival function as it protects against physical harm or death due to potential overdose. Here's an example of how this might work. Take 100 lab rats. Turn half of them into opioid addicts by dosing them enough times to develop strong pharmacodynamic tolerance and withdrawal, i.e. to develop physiological dependence on the drugs. Separate them into 2 equal groups. Then grab your naive, non-opioid user rats. Give all of these rats, users and non-users, a putatively lethal dose of opioids, but dose half of the opioid-dependent rats in a novel box, a new crib, so to speak. Dose the rest of the addicted rats in their usual dosing box. Watch what happens. Almost all of the naive rats die. You just gave them a lethal dose. Duh. Oodles of the drug-dependent rats who are dosed in a new box also die. However, most of the opioid-dependent rats dosed in their usual crib survive. Why? The condition cues of the dosing room trigger situational or anticipatory tolerance, which protects against the subsequent lethal overdose. Memo to your drug-using clients and friends: to stay alive, always know what you are taking and always follow the same rituals in the same places and with the same people. This is situational or conditioned tolerance. So what's conditioned withdrawal and how does it play into the opponent process explanation of craving level addiction? Imagine finding yourself in a place or with people or doing things that you do when you get high. Also imagine that you currently have no intention to get high. These situational stimuli will trigger your body to enter adaptational mode. Once in adaptational mode, if not followed by actual ingestion of the drug, if you don't follow it by actually dosing yourself with the drug, this adaptational state is experienced and actually is pharmacodynamic withdrawal. This pharmacodynamic withdrawal then triggers the drug-seeking behavior, the craving, at least according to the opponent process model. Conditioned withdrawal, according to the proponents of opponent process, is the explanation for craving and drug seeking in people who have developed pharmacodynamic tolerance, but who are not at the moment in a state of drug-related withdrawal. It is offered as the explanation for the pervasiveness of craving that occurs well beyond the drug use withdrawal period. In summary, the opponent process model of addiction. The addict, the craving level addict, has developed pharmacodynamic tolerance and withdrawal, i.e. is quote unquote dependent on the drug. This pharmacodynamic process has become conditioned to non-drug cues, and in the presence of these non-drug cues, or during the period of blood drug level drop, withdrawal is experienced along with a drive to relieve oneself of the noxious withdrawal symptoms. Withdrawal is experienced along with a negative reinforcement drive. Although the opponent process model of addiction is elegant in its simplicity, it does not pass muster with regard to the evidence base. The data simply do not support the theory. Among the data, we have learned that drug seeking and withdrawal in humans and in rats just don't seem to be correlated. Withdrawal doesn't trigger drug seeking in the patterned way that the opponent process model asserts. Even when accounting for conditioned withdrawal, the patterns of use observed in opioid addicts does not conform to that which is predicted by this model. Furthermore, as a noxious event, opioid withdrawal is simply not that bad. There are many more noxious human experiences. So it is very difficult to support a theory tied to relief drugging, even if the explanation is putatively grounded in neurophysiology. The opponent process model elevates physical pharmacodynamic tolerance to the position of a core explanatory principle. One becomes physically dependent, and then one craves the drug, seeks it, does it over and over again, etc., as a means of fending off the noxiousness of withdrawal. We now know that this is simply not the case. Physical dependence is something that happens as a function of repeated use of one of the class of drugs that induce pharmacodynamic tolerance with repeated use. Opioids, ethanol, barbiturates, benzodiazepines. Physical dependence is not the cause of addiction. Rather, it is a health consequence of repeated use of one or more of these drugs, both by people who are or become addicted, and also by others who never become a drug addict. Therefore, we must look elsewhere for a credible explanation of the craving level addictive phenomena. Physical dependence is a consequence, not a cause of addiction. What's the evidence for this assertion? Here are some biggies in this regard. The Vietnam veteran heroin smokers were all pharmacologically dependent on opioids, and most did not go on to a lengthy career of addiction once stateside. Natural recovery from heroin addiction is a well-documented phenomenon. People with oodles of pharmacodynamic tolerance and withdrawal are nevertheless able to remit if and when they make a firm decision to so do. And in the rat brain, the regions responsible for pharmacodynamic dependence and craving are distinctly different. One can create high levels of dependence by stimulating the PAG, and yet the rats do not show evidence of craving or addiction. However, if the VTA is stimulated, one sees evidence of drug-seeking behavior, even in the absence of pharmacodynamic tolerance. The final nail in the coffin of the classic opponent process opioid model of addiction occurred in the 1980s with the onslaught of the crack cocaine epidemic. Cocaine is a highly addicting substance, and it does not cause pharmacodynamic tolerance and withdrawal. It simply doesn't have the same mechanism of action in the brain. In fact, prior to the crack cocaine epidemic, the considered professional assertion was that cocaine was, quote unquote, not really an addictive substance. It was considered psychologically addicting as opposed to physiologically addicting. The addictions field was so wedded to the opponent process model that it simply could not conceive of a drug that did not induce pharmacodynamic tolerance and withdrawal as being an addictive substance. By the way, I will argue later that cannabis is likely truly just psychologically addicting, but that has nothing to do with the presence or absence of pharmacodynamic tolerance. It rather relies on the inefficiency with which cannabis impacts the midbrain dopamine system. How can a substance that does not follow the opponent process model be so addicting? There needs to be a different way to understand the neurophysiology of addiction to explain the commonalities across cocaine, opioid, and alcohol addiction. And we turn to that now. Out with the old, in with the new. The proponent process model of addiction, otherwise known as the incentive sensitization or dopamine model of addiction, is to what we turn presently. And we now must look at the difference between wanting and liking. Motivation and pleasure are mediated by different brain systems. Motivation, the drive towards or away from a stimulus, is conceptually, functionally, and neurophysiologically distinct from hedonia, the experience of pleasure and pain. This is an important assertion, as the two have been inaccurately conjoined, both with regard to conceptions of the fundamental nature of addiction, and also with regard to the understanding of the function of dopamine receptor systems, especially the DA midbrain systems. With the onslaught of the cocaine epidemic of the 80s, the prototypic addictive substance became cocaine instead of opioids. And neurophysiologists turned to the pharmacodynamics of cocaine in an attempt to identify a suitable replacement for the discredited opponent process model of craving level addiction. The result of this was the incentive sensitization, proponent process, or cocaine model of addiction. At the center of this model is the neurotransmitter dopamine, and especially its action in the midbrain. Robinson and Berridge, among others, observed that midbrain dopamine modulates the strength of reward-seeking behavior, and that all drugs with addictive liability, one way or another, trigger increases in midbrain dopamine. It is this phenomenon, which all occurs subcortically and is therefore implicit, that explains both the process of craving and also why certain substances are more addicting than others. Substances, activities, human endeavors that elevate dopamine, especially in the midbrain DA system, have incentive salience, have motivational significance to the individual and to the species. Stimuli, large and small, impact the DA system. Those stimuli that are paired in time with DA elevations, and there are many ways to elevate available dopamine, come to have incentive salience. They get burned into your brain as necessary for continued life and survival. Thus, we are hardwired to experience DA bursts when satiating our basic needs, such as hunger, thirst, and procreation, when running like hell when a mastodon is coming after you, etc. Within this midbrain dopamine system, or rather without this midbrain dopamine system, you would likely have a lot of skinny, half-munched up humans without any offspring. The activities in the midbrain DA system reflect pretty basic stuff. Incentive sensitization occurs subcortically as a function of action in the midbrain. By definition, subcortical functions are not cognitively mediated. There simply is no conscious or potentially conscious component of the incentive salience process. The process is deduced by third-person observation. It is not reported or reportable by the first person. Phenomenologically, incentive salience is experienced as a drive to do something repeatedly. In the context of craving-level addiction, it is experienced as a visceral urge to use drugs, very similar to the urge to flee danger. However, in the drug case, there is no cognitive understanding of why the urge is present. That's a very big difference and offers support for the experience of many addicts who, when asked, "Why did you relapse?" have no coherent response. This is not denial. It's simply the way things are when mechanisms of action occur outside of the cerebral cortex. The putative causal mechanism of the proponent model is implicit wanting. This is often called core wanting as opposed to cognitively mediated conscious wanting. Historically, there's been a misunderstanding of the function of dopamine. For many years, addictionologists would assert that DA was the, quote, pleasure neurotransmitter, modulating or marking the experience of hedonic reward. This is simply not true. Dopamine in the midbrain marks motivational salience. Hedonic processes are impacted by other neurotransmitter systems, by actions at other neurotransmitter sites, including the opioid, nicotinic, and cannabinoid transmitter systems and sites. If you run into somebody who continues to insist that dopamine modulates the experience of pleasure, slap them silly. The hypothesized causal mechanism in the now discredited dopamine pleasure hypothesis is implicit liking. Simply not the case. And we have all sorts of evidence to refute this DA pleasure neurotransmitter assertion. Rats bred without dopamine receptors, so-called dopamine DA blocked rats, experience sugar as pleasurable, but show no drive to push a lever in a Skinner box to receive a dose of sugar water. Dopamine depleted cocaine users experiencing DA depletion after an extensive episode of use no longer show an addictive drive, even though they still experience pleasure associated with intoxication. Parkinsonism patients who receive DA enhancers to treat their symptoms show behavior that is analogous to craving level addiction, but do not experience pleasure associated with the actions that they pursue. The literature on this phenomenon is actually quite fascinating. There are a variety of DA receptor-rich regions in the brain. The two that are implicated in addictive processes are the midbrain, ventral tegmental area, and mesolimbic systems, and the prefrontal cortex. The midbrain systems are most directly implicated in the craving level addiction process, and that will be our current focus. We will discuss the manner in which changes in the prefrontal cortex DA system impact the intoxication and addiction experience later in this lecture. The process of incentive salience occurs in the mesolimbic dopamine system. Conversely, the mesocortical dopamine system modulates changes in executive cognitive functions as a function of intoxication. Dopamine is a very interesting neurotransmitter that has been implicated in the etiology of a number of varieties of psychopathology, including major depression, schizophrenia, cognitive dysregulation, and substance use disorders. Decreased DA is likely at the core of the anhedonia, often seen in major depression, and is also the reason that many people on antipsychotics are so apathetic. The antipsychotics decrease available dopamine in the midbrain. Theoretically, for the purpose of decreasing the salience of the positive symptoms of schizophrenia, including delusions and hallucinations. Prefrontal cortex dopamine systems are likely involved in at least one variant of attentional dysregulation of ADHD. So there's a lot to learn about the roles of DA in psychopathology. Again, DA modulates the core experience of implicit wanting, the drive to seek a given reward or reinforcer. Dopamine does not mark, nor is it in any way involved in the experience of liking or hedonic pleasure and pain. This wanting process is implicit and does not have any cognitive components, correlates, nor does cognition in any way mediate the incentive salience process. Wanting increases over time. Incentive salience gives way to incentive sensitization. The motivational salience of a stimulus that increases available dopamine increases over time. This is a process called incentive sensitization, and we will discuss it shortly. It's a function of time, a function of dosing. Implicit wanting increases. The drive increases. This is the opposite of what happens with tolerance. Liking, however, decreases as a function of repeated doses of most addicting drugs. This is a function of pharmacodynamic tolerance with the depressant drugs, the decreased A state that we discussed earlier, and is due to neurotransmitter depletion with the stimulant drugs. Two different processes, same phenomena. As one advances deeper into craving level addiction, fewer and fewer drug-using events are associated with hedonia, pain removal, or pleasure experiencing, either before, during, or after drug use. Addicts have been reporting this forever, but we have not listened to them, preferring to attribute their report to quote-unquote denial or character immaturity. Individual differences in the rate, intensity, and duration of both incentive salience and incentive sensitization are marked. Different folks' dopamine systems function differently. Also, environmental contexts will impact one way or the other the rate and degree of incentive sensitization. All of this explains why the base rates of craving level addiction are so low, i.e., many people who use drugs that impact dopamine do not become addicts. and why the base rates of craving level addiction are so varied. Addiction, craving level addiction, is simply not reducible to a function of a pattern of drug use over time. It occurs in biochemical, biogenetic, and environmental contexts. Not only does the DA hypothesis provide a coherent explanation of the addictive process, the efficiency with which a drug of abuse triggers an increase in available midbrain dopamine actually serves as a metric of addictive liability. The stronger the DA elevating effect at the midbrain, the more addictive the substance is to the human user, as well as to the white lab rat. Dopaminergic effects of drugs. Cocaine is at the top of that list. Interesting, drugs that do not trigger DA bursts do not show evidence of the same addictive liability. In the case of benzodiazepines, this is so even though benzodiazepine users experience pharmacodynamic tolerance and withdrawal. So with benzodiazepine, we have a drug which reliably induces pharmacodynamic tolerance and withdrawal as a function of time, the amount of benzo that you need to ingest to experience the same therapeutic dose, therapeutic phenomena, therapeutic experience increases, and when you stop using benzos, you experience withdrawal. However, the base rate of benzodiazepine craving level addiction in the absence of craving level addiction to other drugs is actually very low. There are a variety of ways in which these substances yield increased availability of dopamine. Some increase DA production at the presynapse, some decrease inhibition or presynaptic release of dopamine, some decrease the rate at which dopamine is metabolized so it remains available at the synapse, some decrease rate of reabsorption. The bottom line is all drugs with craving level addictive potential when ingested yield increased available dopamine in the midbrain DA system. This figure depicts the various sites of action of drug metabolites in the midbrain system. I show it here just to emphasize the variety, the various ways with which substances of misuse, substances with craving level addictive potential, impact the same system. Let's turn back to incentive salience again. Very important concept. What is incentive salience? Again, life-preserving actions are associated with dopamine bursts, which mark the action as salient or necessary for self-preservation. Drugs with addictive liability mimic this evolutionarily necessary process. When ingested, the drug acts on the midbrain dopamine system in a manner that mimics these fundamental, evolutionarily essential, life-sustaining neurophysiological processes. Drugs, therefore, are said to hijack this midbrain dopamine system. The DA burst associated with ingestion of a drug with addictive potential marks the salience of that drug-taking behavior, as well as any non-drug stimuli associated with drug ingestion. Classical conditioning, whatever has occurred contiguous to the DA burst, becomes marked as salience for survival. So once again here, classical conditioning serves to generalize the incentive salience phenomenon. In addition to drug stimuli triggering DA bursts, non-drug conditioned stimuli also come to trigger DA bursts, which stimulate the same drug-seeking urges and behavior. Conditioned stimuli trigger the same do it again, do it again, do it again, motivational, implicit motivational phenomenon. The incentive salience sensitization cycle is an interesting one. Drug-induced dopamine bursts set the stage for quick conditioning of related non-drug stimuli. The importance of this to species survival should be clear. The more cues you have to survival-related activities, the better. It's always good to know the train's about to run you over when you can see it 2 miles away rather than at 100 yards. Once conditioned, these non-drug stimuli trigger dopamine mini bursts on their own. These bursts are both reinforcing in their own right and also start the positive reward drive that defines craving from the proponent model perspective. It's like your brain gets a small taste of what's to come with actual drug ingestion. So what causes craving? This phenomenon that is at the core of our understanding of true drug addiction. Let's look at how models of addiction understand craving. From the opponent process perspective, craving is a negative reinforcement process triggered by the experience of real or conditioned withdrawal symptoms. Withdrawal symptoms triggered actually by blood drug level drop or situational or conditioned withdrawal symptoms. The drive that is mediated by craving is to be relieved of these noxious experiences. Social learning and expectancy models, to which we'll turn at another time, understand craving in terms of cognitive mediation. In certain situations, positive expectancies are brought to the forefront and then guide the individual's drug-using behavior. From the proponent perspective, craving is a positive process of moving towards an anticipated reward. The process starts when conditioned or unconditioned stimuli prime the midbrain dopamine pump, so to speak. Proponent process, craving, the urge to use, is a function of moving towards a positively reinforcing activity or event. Opponent process, craving, that drive to reinstate drug use, is a function of moving away from noxious, negative stimuli. Fundamental difference. The positive craving process of the proponent process is rapidly triggered by very small levels of stimulation, such as subintoxicating doses of a DA-enhancing drug, or by the presence of conditioned non-drug stimuli. It takes very little to prime the pump, to create the urges, especially in a sensitized brain. The more sensitized one's brain, the smaller the priming dose, the smaller the stimulus has to be to get the craving process, that drive process, that drug-seeking process going. Think of this as the stimulation of an appetitive drive, such as what happens to many of us after having the first Lay's potato chip. The consequent positive craving grows quickly in intensity, especially, as I said, in the sensitized brain. There are some other features of this priming effect that are worth noting. Cross-priming effects have been observed such that non-related DA-enhancing activities will prime urges towards other DA-enhancing activities that are unrelated. This is seen in situations where one quote-unquote addiction is substituted for another, for example. We also know that stress itself primes drug-seeking behavior. Experiencing a high level of stress in and of itself triggers DA bursts, and these then sensitize the brain to the DA-enhancing effects of drugs of abuse. Thus, the off-cited PTSD substance use connection can be explained at the level of neurophysiology rather than needing to invoke psychodynamic or other putative psychological processes. Having experienced stress, your brain becomes sensitized. A sensitized brain is ripe for developing the conditioned sensitization associated with any other dopamine-enhancing activity, ingesting drugs included. The direction of the priming also goes the other way, by the way, such that brains sensitized to the DA-enhancing effects of drugs also become sensitized to the DA-enhancing effects of stress, which increases stress reactivity, i.e. lowering the threshold for experiencing panic and a loss of coping efficiency. So the stress-substance use connection can be cogently understood at the level of neurophysiology. The proponent process model asserts that drugs with addictive liability throw a 1-2 punch at the human nervous system. Beyond the initial DA bursts, we have a second phenomenon called incentive sensitization. We've introduced this, now let's look at this a little more in detail. Incentive sensitization refers to the fact that with repeated exposure, the midbrain DA system becomes sensitized to the effects of, say, cocaine on the DA system. With each subsequent episode of drug use, the DA system requires smaller and smaller levels of the drug to experience the same DA hit. This is not a psychological process, this is a neurophysiological process. Smaller and smaller levels of the drug generate the same size of increase in available dopamine in the midbrain DA system. This process is the opposite of tolerance, where over time the drug-induced effects decrease. At least at the level of the dopamine system, each subsequent dose yields increased effect. This phenomenon of sensitization endures, often for the lifetime. This is very important to appreciate. Once sensitized, the brain remains sensitized. A sensitized brain remains so, and this explains a few facts. One, it explains why after a long period of abstinence, an individual with a drug-sensitized brain may suddenly experience strong drug-seeking urges. Two, it explains why abstinent addicts often develop other non-drug, quote-unquote, addictions. The brain has become sensitized to the DA-stimulating effects of anything that functions in that manner. And we know that in addition to DA-enhancing substances, there are many DA-enhancing activities not the least of which is gambling. There is evidence that sensitization is in part a function of morphological changes in the neuronal system. Self-control. Self-control is the cornerstone of effective self-change, and it is seriously challenged by the sensitized brain. Incentive sensitization makes self-control exceedingly difficult. Self-control is a function of desire, translating in commitment, translating into intention in action. I make a commitment, I frame an intention, and then with that in mind, I take actions or avoid taking actions. With the sensitized brain, this fundamentally human process of intentionality becomes exceedingly difficult. In a later lecture, we will discuss the similarities in the prefrontal cortex functioning of children and adults with ADHD and individuals who are acutely intoxicated. At this point, suffice it to say that in both conditions, we observe pathological changes to the DA system in the prefrontal cortex. Whereas the DA system in the midbrain modulates incentive salience, the DA system in the prefrontal cortex modulates executive cognitive functions. The mesocortical DA system modulates changes in executive cognitive functions associated with acute and chronic intoxication. Although overly simplistic, essentially the elevation of DA levels in the prefrontal cortex knocks out PFC-mediated executive cognitive functions. Planning, perspective taking, impulse control, and other ECF processes temporarily go offline. This again has important evolutionary roots. If one is in fight or flight mode, one does not want to expend too much time and effort sweating the details. Rather, one wants to either run like hell or fight like hell, and neither of these activities requires highly tuned executive cognitive functions. Turning back to the human process of desire, leading to intention and commitment, leading to intention and action, self-control, the cornerstone of self-change, is markedly impaired when one combines incentive sensitization and executive cognitive function knockout. The self-control double whammy, that is the enduring experience of craving level addiction. And it's at this point that we'll end this lecture.